prime number. Even numbers can never be what? A prime number. Right? Guys, if you have one even number here, you cannot have another even number to be a prime number. It cannot work. You get it? Do you understand? Very good. So now, if we have numbers from 1 to 30, which among them are prime? 3. Right? 3. Should 3 be a prime number? What about 1? 1 can go into 1, right? So let's start with 3. Okay, if we say 3 is a prime number, the next prime number will what? 5. Okay, if we take 5 as a prime number, next one, 7. 7 is a prime number, next is what? 9. If you take 9, 3 can go into 9. So 9 cannot be a prime number. You understand? So we cannot. Prime number, yes. So 11. 11, yes. Which one again? Very good. 13. Which one again? 17. 17. Yes. Another one. 19. Yes. Yes. What about 21? Very good. 21 is not a prime number. So next one is what? 22. Very good. 23. Followed by what? 25. 27. 27. 3 can not go into 27. 3 can go into 27, right? So which one again? 29. And what? That's all, right? Okay, these are prime numbers. Now, cross check one by one. 3, 5, 7, 11, 13, 17, 19, 23. There is no further number that can go into all these numbers except 1, right? So these are prime numbers. Now let's go to the question. I think we have defined all the sets given to us here. Okay, now let's go to the set, the question number 1. Number 1, we're asked to find A intersection B. Now, what is the meaning of intersection? What is the meaning of intersection? We made an example the last time. If, now, let me say, everybody in this space, we are all from different schools, right? We're from different schools. We have people from Amadu Ibadu, people from Suleiman Ibadu, people from EUN, people from Ibn Abbas, people from Nana Aisha, all those big schools. Now, we also have those that are in science, those that are upper science. We also have those that are in arts, right? We have those that are in commercial. Okay, what and what do they have in common? Let me say, do they normally have a general class? A general class? Very good. What are those general subjects they cover together? That is intersection. You understand? Another example, if I should say now, if everybody here has a purse, I'll say, okay, everybody look at your purse. What do you have? What everybody here has? Okay? Everybody has money, but if I say check your pocket or check your purse, what do you have? Everybody has money. So if you have money, that means that's what you have in common, right? So what are those things that set A and set B have in common? That is intersection. Is that okay? Now can we list those elements that they have in common? Look at, first of all, look at A and look at B. What does A have? That what do you see in this set, in set A, and you also find in set B? What are those things? 5. It's an empty set. First of all, 8. A set of what? Odd numbers. B, a set of what? Even numbers. You cannot have anything in common. Odd numbers and even numbers are both what? Opposites. You understand? So we are going to have an empty set. So we just draw an empty bracket, open it, and close it back. Empty set. That is the final answer. Do you understand? We are done. That is the final answer. Is that okay? Yes. Now let's go to the second question. Okay, now if we are to draw, Venn diagram of this set, how do we draw it? We just draw set A, we draw set B, nothing inside. Just leave it like that. Empty. Understand? Nothing. Alright, now I hope you are aware that this is where we have the intersection, right? Yes. Where A and B intersect. That is the intersection. So what I think we have something in common or they have a number that appeared in both sets, we'll put them here. Is that okay? But since they don't have, just leave it empty. Is that okay? Second question, please. Second question. B intersection C. B intersection C. Everybody, look at set B. What are those things that are in B that are also in C? Check properly. What are those things we can find in B and can also find in C? Empty, right? Yes. So we also draw open bracket and close the bracket. So this is for 1. For 2, the same thing happens. So this time around, it's going to be set B and set C. Nothing. Just intersection. Just leave it empty. Is that okay? Yes. Very simple, right? Alright, the third question. The third one. The third one. A intersection C. We have A intersection C. Alright. What are those things that A and C have in common? 3. 3? 5. Okay. Let's list them one by one. A has 3. Do we have 3 here? Okay, we have 3, comma. 5. Yes, 5. 7, comma, 7, 11, 13, 17, 19, 23, and 29. Okay, now let's start one by one. We have 3 here. We have 3 here. We have 5. We have 5. We have 7. There's 7 here. We don't have a 9. We have 11, there's 11, 13, next 15, no 15, we have a 17 there, 19, next 23, 25, no 25, 27, no 27, but there is 29. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's what we have. 1, 2, 3, 4, 5, 6, 7, 8. Wow. What is missing? What is missing? We have 3, we have 5, there, we have 7, 11, 13, yes, 17, yes, 19, yes, 23, and what? 29. Okay, it's complete, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 6, okay, we are correct. Alright, now, if that is the final answer, how do we draw the Venn diagram? Remember, there are going to be just 2 sets, right? Yes. One will be A, and one will be C, right? Yes. Okay, now what are those elements that A and C have in common? Now, we see that there are 9 here, right? So we have to extend this so that it can accommodate 9 elements. Understand? 9 elements. All those things that we are written here, we are going to write in here. So we write them one by one. We have 3, comma, we have 5, comma, we have 7, we have 11, we have 13, we have 17, we have 19, we have 23, and we have 29. Can we see that? I hope you understand. We all know where to write those elements that intersect, right? Any question? Alright, what's your note? So important. Where is Aisha Jada? Oh, she has gone back to work. It's okay. Now let's continue the 4th question quickly. Number 4. What are we looking for? Alright, B intersection C. Well, should that be a problem? Should that be a problem? B intersection C. What's the answer for B intersection C? Empty. Is it empty? No. Yes. Are you sure? Yes. B as set of even numbers, then C prime numbers. Even and prime. Do we have anything in common? No. We don't have. Are you sure? Yes. Very good. So if we don't have, we just write an empty set. Remember the diagram, right? We just draw 2 sets, one B and then one C. Make it like that. Nothing. Empty. Very interesting, right? Number 5. Number 5. Yes. B intersection what? B intersection universal set. What are those things you can find in the universal set? I can also find V. 2.
Yes.
Yes.
2, 4, 6, 8, 10.
We have from 2 to 30, right? So we can say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 28, and 30. Right? Now let's draw the Venn diagram. Remember the Venn diagram. Now, wait. How do we draw the Venn diagram now?
It will be
Big.
yes.
How many? Very good. Now look at something. Listen up.
15 digits. 15 digits.
Remember, last week we were trying to define a superset and an ordinary set, right?
Yes.
We said what is the difference between a superset and an ordinary set? What did we use? What's the difference? Yes, Ahmed. Superset. Yes. A superset. I use Wilson as a grandfather. If Wilson is a grandfather, then we have other parents, other fathers who are what? Bello, they have the Aminos, and then this Bello and Amino have children. Who are the children? You. Very good. Now, very good. So what happens now to Wilson? Wilson becomes what? A superset. So that means it's B here. This U here is a superset, right?
Yes.
A, B, C are all what? All other, they are still set. Do you understand? So all these elements, these ones are what? Sub-elements. Do you understand?
Yes.
So now, how many sets are we going to draw here? We are not going to draw two separate sets like this. The B set, because we have the universal set, we are going to draw one set.
Yes.
Followed by what? Followed by what? You know this big one, we call it universal set. Then what again with it? Okay, we are going to draw another set inside this one. This set what? B. You understand? There. All these elements here are going to be inside. They are still part of the B. You understand? So we pick them here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. This is our pen. You understand?
Yes.
I hope you understand. This is inside the superset, or it's inside the universal set. And all these elements are elements that are found where? In B. So we cannot take it anywhere. We'll put them there. You understand?
Yes.
Is it interesting?
Yes.
Is it confusing?
No.
Are you sure? Mariam? Confusing? Alright. Is it the last one? We still have another one?
Yes.
Alright. That's it, C intersection. That's the last one.
Yes.
Alright, let's have the last one. C intersection universal set. Now, C intersection universal set. If we have D intersection universal set, means all the elements that are in D. Then what about C intersection universal set?
Yes.
All the elements will also in what? The C. So from 3, 5, 7, 11, followed by what?
13, 17, 19, 23.
13, 17, 19, 23, and what?
29.
29. So how do we draw the universal set? Anybody?
Draw.
Yes?
Draw the.
So we draw the same thing like this, right?
Yes.
We draw it like this.
So do you know how you make it?
We make U here. Then we also make
that one.
another one like this.
Yes.
This time around, this one will be what?
C.
C. What do we write?
Yeah.
All these elements, right?
Yes.
3, 5, 7, 11, 13, 17, 19, 23, and what? 29. Is that okay?
Yes.
Alright, now, how was it difficult? Was it simple? I believe you think you can solve any problem in sense. Yes? Any. Okay, I don't believe this one should be a problem. Alright, let's take that down quickly. So that we can go into our discussion for today.
Hello, Zubair. The two of you were not present on Friday, were you? What happened? Uncle Anthony has not been coming. Yes.
The problem now. The W and X. And then looking at Q, we have another number. Starting from 2, 2, 3, the remaining are what? Alphabets. U, V, W, then 5, 6, then Y again. Okay, look at R. So how do we solve this class? How? Okay, first of all, let's consider this. Say let P minus Q intersection R be equal to set of K. Is that okay? Is that okay? So that means everything here will be equal to K. Alright, now let's look at this one. What is set P minus Q? Set P minus Q, how can we solve this? Set P minus Q is simply as what? Set of P minus set of what? P intersection Q. That is what we have. So now, what is set P? Can we name set P? We have what? 1, 2, U, V, W, X. Minus. Now, what is set P intersection Q? Look at P intersection Q. We said intersection, those elements that they have in common, right? 2. All right. We have what? 2. Yes. Then what? 1 is, we don't have 1 here. We don't have 2. What about you? U. V, yes. W, is that all? Is that all? What about X? No X. So that's all. So this is what we have. Now can we subtract these two? What do we have? Let's subtract. What do we have? If you have 1, 2, U, V, W, X, you subtract it from what? 2, U, V, W. Subtract. This and this goes, right? This and this goes. This and this goes. This and this goes. We're left with what? 1 and X. So that means that P minus Q is equal to what? 1 and X. Have we solved the problem? No, we have not finished. We have just solved just one part. So if this is P minus Q, remember, K is equal to what? K says we should find P minus Q intersection R. So we have successfully found P minus Q. So we're looking for R intersection R. So now let's bring down this. What do we have? 1, comma, X intersection what? What is set R? 2, 3, 4, G, X, and Y. Now, what are those elements that we can see here that are also here? Yes? Do we have any?
Yes, X.
Which one?
X.
We only have this. What about the remaining? No. So our answer is X. We have X in the option here. D. Very good. Is that simple? Alright, now let's put this down. You know where the problem? Everybody will have always ask, what is this? How can we do this? Equality is this. What type of inequality? Now look at this. We have 2. We have how many terms here? We have 3 terms. We have the first term, second term, and the third term. Now look at the highest power of the unknown. X is the unknown, right? The highest power of unknown is what? 2, meaning it's a quadratic inequality, right? Quadratic inequality. So how do we solve quadratic inequalities? We can either solve it using normal factorization method, using completing the square method, or using what? The quadratic formula method. Is that okay? All right. Now when you look at this, how do we solve x? Because what the question is to solve this inequality. Solving this inequality means finding the value of what? X. And remember, if it is a quadratic inequality, you're going to have 2 answers, right? So x, one might be positive, one might be negative, 2 of them might be positive, or even you might even have 1 answer. X can be equal to an answer and it can be twice. Is that okay? All right. Now, how do we solve this? Anybody? Any idea? What do we do? What do we do? Yes, what do we do? Okay, look at something. Remember, inequality signs are being affected if and only if what happens? The sign changes when what happens? When either you multiply the variables by a negative value, when you multiply this variable by negative value, this inequality sign changes to the opposite direction. Same thing. We either multiply or divide. Another way, the sign change. This inequality sign. This sign stands for what? Greater than, right? Greater than. That means the value of 2 minus x will be what? Greater than what? X. X squared will be greater than the x squared. So no matter what x is going to be, when you subtract x from 2, the final result will be greater than this answer. And now what is x squared? How can we find x? Very good. Now for us to be able to solve this problem, first of all, you take everything on this side to this side. Is that okay? Is that okay? Are we following? By taking everything on this side to this side, that means we're going to have something like this. First of all, let's take this to this side. By taking this to this side, how do we eliminate x here? How? How do we eliminate this x squared? How do we make, in a quadratic equation, we must have the equation on one side, and the other side we have is 0. Is that not so? So how do we make this right hand side to be 0? How? Very good. We add minus x squared to both sides. Is that okay? So we are going to have what? This one will be what? Minus x squared plus 2 minus x greater than what? X squared minus x squared. We following? We added this value, but negative form. So that this one will be 0. Now this one will be what? Greater than 0. Are we following? Are we following? Please, do you understand? This side now will be 0. But what happens to this one? This one we are going to have minus x squared plus 2 minus x greater than 0. Is this a quadratic equation?
Yes.
Are you sure?
Yes.
Very good. But this is minus x squared. So what happens? Can we go on and factorize? Can we go on to factorize? We cannot factorize. So what do we do if we cannot factorize? Any idea? Okay. No, we can't factorize. Well, look, don't worry. Okay, if we are using the general formula method, is the easiest method of doing it. That is by making x minus b plus or minus square root of what? B squared minus 4ac all over 2a. Now, when we compare this, we compare minus x squared plus 2 minus x. First of all, rearrange this to look like the real quadratic expression. ax squared plus bx plus c is equal to 0. Rearrange this. What are we going to have? Minus x squared minus x plus 2 greater than 0. So this will be what? Minus x squared minus x plus 2 greater than 0. Now, please, everybody, look at this. Look at what we have. Do we have x squared here? Do we have x squared here? What is the coefficient of x squared here? A. Coefficient of x squared here is what? A. Coefficient of x squared here is what? Please look at it. Look at only the coefficients. You are only interested in the coefficients. What is beside x squared? What is beside x squared here? That is the coefficient. What is beside x squared here? A, right? What is beside x squared here? Minus, there's no 1. But if there's no 1 here, look at it. It's just minus x. Minus x means what? Minus 1. There's no number. So the minus number is minus 1. You understand? Maria, are you following? Everybody, are you following? Amina, are you following? Now let's go forward. What is the coefficient of x here? B. Look at it. Coefficient of x here is what? We are now done with the first term. We are going to the second term, which contains p, dx. So what's the coefficient of x here? B, right? Right, b is equal to. What is the coefficient of x here? Minus what? Good. Minus 1. We are done with the second term. Now let's proceed to the last one. The last term. The last term here is what? C. Do we have C here? C does not have an x parameter. You understand? So what is the value of C here? The value of C here is what? Is it? It's greater than 1. It's 127. What is the value of C here? Good. We put down our 2. And we are finished. All we need to do is what? Substitute these values into this expression and then solve. Can we do that? Can we try that? Please, I know some of us are confused. Now let's go back. This is the general quadratic expression. Quadratic expression is given as what? Ax squared plus bx plus c equals to 0. Now this is the quadratic inequality. We simplify it and make it look exactly like this quadratic expression. So when we simplified it, this is what we had. Right? We had x squared minus x. Initially, this is what we had. Minus x squared plus 2 minus x. We will have to rearrange it to be in this form, where we start from the highest power, which is 2, followed by 1, then 0. You understand? We know that here we have x to the power of 2 plus x to the power of 1 plus x to the power of 0. Do you understand? X to the power of 0 is in indices is 1 plus x to the power of 1 plus x squared. That is what we did. We arranged them in what? In decreasing order. So that's the same thing we did here. You understand? So we now look for the coefficients depending on which method you want you to solve. Using general formula method. This is the general quadratic formula method. This is the formula. Or we use factorization. We can factorize. Of course, we can do it. Then, or we can use computing the square. But we are looking for an easier method how to solve this. And that's the quadratic formula. Another easier way is using factorization. But let's try it. So let's substitute the values. X is equal to, what is our minus b? We have minus first. So we write our minus first. What is our b? What is our b? Minus 1. It's not 1. It's minus 1. So let's put in bracket minus 1. Close the bracket. Plus or minus. We have root of. This time around we have b squared. What is b squared? We put it in bracket. Minus 1 squared. Are we following? B squared followed by what? Minus 4 times what is A? Minus 1 times what is C? 2. Everything here divide by what? 2 times what? Minus 1. Are we following? Alright. x will be equal to, now look at it. Do you know why I put it in bracket? So that you will not be confused. Because we have negative values. We have also negative parameters here. So when you put it in bracket, it will be simpler for you to solve and it will be easier. You get it? So now, minus times minus, what are we going to have? So we're just going to have 1. You understand? So then what do we have? Plus or minus, plus or minus, square root of what? Minus 1 squared. Minus 1 squared. First of all, minus squared means what? Minus times minus, right? So minus times minus is going to be what? Plus. So the negative sign goes. 1 squared is what? So we have our 1. Are we following? Are we following? Now we have minus 4 times minus 1 is what? 4 times minus 1. 4 times minus 1 will be what? Minus, no, it's not minus 3. We are multiplying. We are multiplying. 4 times, okay, 4 times 1 is what? What's that? Minus. Minus follows it, right? So 4 times minus 1 is what? Minus 4. Minus 4 times 2 is what? Minus 4 times 2. 9. Minus 4 times 2 is what? Minus 8. So we open bracket, minus 8. We close it up. All divided by what? 2 times minus 1 is what? Minus 2. Please, are we following? Are we following? Ibrahim, are you following? Alright. So, now please look at this. X is equal to 1. We have 1 plus or minus. Now, what do we have in the bracket? 1. What happens to the minus? Minus times minus is what? Plus 8. All over what? Minus 2. So, if we simplify this, this becomes what? We have 1 plus or minus root of what? 1 plus 8. 9 divided by minus 2. This will give us what? We have root 9. We did sort, right? So we have 1 plus or minus square root of 9 is what? We have 3 all over minus 2. Now, this plus or minus means you're going to have 3 answers. We're going to have x is equal to 1 plus 3 all over minus 2, or x equal to 1 minus 3 over minus 2. Are we following? So, x is equal to 1 plus 3. 4 divided by minus 2, or x equal to 1 minus 3. 1 minus 3. 1 minus 3. We have minus 2 all over minus 2. Okay, so x is equal to what? 4 divided by minus 2. 4 divided by minus 2. Okay, 4 divided by 2. So what about the minus? The minus follows it, right? This minus is very powerful. Alright, or minus 2 divided by minus 2 is what? Okay. First of all, minus times minus. Abi? 2 here. 2 divided by 2. So, we have just 1. Is that also? Are we following? Hello? Any confusion? No. Any confusion, please? Yeah. This is a plus or minus. Look at the plus or minus. Look at the formula there. Oh, sorry. Thank you. Thank you very much. All right. So please look at the answer. X is equal to minus 2, or x is equal to 1. Now look at it. What does that mean? X is equal to minus 2, or x, or x is equal to 1. All right. Now, how do we represent this? How do we represent this? How do we represent this? First of all, if x is equal to minus 2, what does that mean? Yes. Everybody, please look at it properly. If x is equal to minus 2, do we have any answer here that talks about x minus 2? Okay, when you look at, sorry, this is still not b, sorry. Now look at, we have minus 2. Do we have minus 2 here? No.
Yep.
We have minus 2 and 1. We have minus 2 here. We have minus 2 here. In between these two are not included. Now, what comes to your mind when you have these two? First of all, look at something. X has two numbers, minus 2 and 1. Which one is greater? Minus 2 and 1. Which one is greater?
1.
1 is greater than minus 2. True or false? Why? Why?
Because these two have minus.
Very good. It has a negative number, right? So that means if 1 is greater than minus 2, then we say x is what? X is what? Greater than minus 2 and what? Less than 1. Is that okay? Is that okay? Okay. What does that mean? This means that this minus 2. If 1 is greater than minus 2, what does that mean? That means minus 2 is less than 1. True or false? Is it confusing? Okay, let's stop. Let's stop. X is greater than minus 2. That means x can be minus 1. Minus 1 is greater than minus 2, right? That means x can be minus 1. X can be 0. And also less than 1. So if x is less than 1, that means x is greater than minus 2. And also minus 2 also is what? Less than